presentation today is going to be a basic introduction to new and current users of the Q-Plex technology, to introduce them to what we have and how things work. Quansys Biosciences began in 2004 to improve the accuracy and efficiency of ELISA-based testing. We are a subsidiary of Spenlove Medical Research Institute, which was founded by Dr. Rex Spenlove. Many of you may be familiar with HiClone Laboratories. Dr. Spenlove was the principal founder of HiClone. When he sold HiClone, he wanted to continue to build new technologies and new companies. He had the idea of multiplexing. Back in the day when they would get multiple lots of serum, they always had to send samples of these lots out to be tested to a variety of labs for a whole bunch of different testing. And they were always frustrated with the quality of testing and the variation they saw in their results. So he always had the idea, wouldn't it be great if we could test for a variety of biomarkers in one sample at one time? And so when I started here years ago after grad school, that challenge was given to me and a few of my colleagues, and we were able to, through time, develop and pioneer this Q-Plex technology. So our tagline is, we specialize in the development and manufacture of multiplex ELISA arrays, which is branded Q-Plex, to be used in protein detection and quantification. The basic layout is in a 96-well plate. We do have applications in 384, but primarily in 96-well plates. We print on the bottom of these plates small spots or droplets of either antibody or antigen. In this graphical representation here, we are printing antibodies down. These robotic handlers spot these 20 to 50 nanoliter spots down. The size of these spots are roughly 350 to 500 microns in diameter. Each spot is a unique assay within that well. One of the good things about the Q-Plex technology is it is very similar to that of a traditional ELISA. In essence, you simply add your sample, you wash your well, you add your detection antibodies, you wash, then you add your detection molecule, whether it be some kind of dye or HRP or some kind of detection model. Following the addition of the reagents, you add a substrate in the case of chemiluminescence. If that antibody-antigen complex is built, i.e. your antigen is present in your sample, a spot will be emitted. Photons of light will actually be generated from the chemiluminescent reaction, and an imaging device will image and create an actual image file of each of those spots luminescing. As you can understand, not all spots will luminesce. Clearly, if no antigen is present, you'll see no spot. But based on the fact that we know we've printed in each of those spots certain antibodies, if there is no light emitted, then we know there's no antigen present. The plate is imaged by a Acuvue Imager, which is a device we manufacture and sell, or other devices that are available in the marketplace. In essence, we are simply taking a picture, as you would in a chemiluminescent Western blot or some application such as that, and you're actually taking one big picture of that plate. So you can understand the critical nature of two things. First, the resolution of the camera should be sufficient so that we can zoom in on every small little spot. And number two, a proper camera that can take long exposures. As we're collecting these photons of light, it's required to have the aperture open for periods of time. So there are only certain devices we have validated and approved, whereas there may be others that will work but may give less than optimal performance. So the image that is taken is then scanned and read with our ToView software. This software will be able to automatically find the spots in each well. It will then look at the standard curve and generate regression models that can then be compared to the unknown samples and deliver known concentrations from those standard curves. There are a variety of regression models available in the ToView software to help that calculation proceed. Reports can be derived from this software, which can include a vast variety of statistics and analysis patterns, and the data can be exported in the format the customer chooses. So as you look at our technology, there's a variety of products we've been able to deliver around this technology. But as a summation, we will test up to 25 unique proteins per well. It does require a low sample volume of 25 microliters per well. So if you want to test your sample in duplicate, you only need 50 microliters to test for up to 25 unique assays. And since it is very similar to that of ELISA, your assay time for a traditional ELISA is around 3 hours. It is quantitative. we are able to quantitate very specifically to what the customer needs. And it's very highly specific. As you can understand, if the specificity was poor, this technology would not work. In the fact, if you added a sample and we only needed to measure IL-2 and other spots lit up or showed a reaction, you could see how that would quickly nullify this concept. So through the development process we have internally, we have protocols that through the development and QC ensure that none of these signals are read from other spots. So that is something we do during development and every time we manufacture these products. Also, due to the fact that we have these small spots, we hyper-concentrate the deposition of antibody in each of these spots. And what that allows us to do is be able to capture a greater signal in proportion to the well background. When you actually have a total ELISA signal from a well, you get a lot of background from the well inherently, and it is unknown to you. Due to the fact that we're able to compare directly to the background in the well, we get a better sensitivity due to signal-to-noise ratio. In the fact that the darker we can make the background around the spot and the brighter we can make the spot, the greater the proportional difference between those two, and hence the better sensitivity. So in this case, we're able to yield higher sensitivity than traditional ELISAs. You will, in many of our cytokine kits, you'll have LLDs or LLOQs in the femtogram per mil range. If you visit our website, you'll see there's a whole variety of products and services that are offered. These assays, the retail kits that you can choose from have a variety of applications. We have a lot of cytokines, chemokines, angiogenesis markers, hormones, MMPs, tumor markers. We have some new diabetes-related markers coming out soon. We have it in a variety of 3 different species, that being human, mouse, and rat, as well as 2 different detection models. For chemiluminescence, we have a variety of kits. And then we also have some kits that are available in IR, meaning they are to be scanned with a Lycor Odyssey scanner. So instead of using the streptavidin HRP, use the streptavidin dye and use your Odyssey to scan the plate. As some of you may know, but we do have demo kits available. This allows you the opportunity to have experience with the Q-Plex technology, learn how it works, learn how to run the kits, how to image, how to use the software, so that when you buy your kits, we can ensure you have a good experience. So as mentioned before, we have built a device that is to be used with this technology. It is called the Acuvue Imager. It is an 18-megapixel camera system. It has an automated image capture. So you simply just put your plate in there, hit select, and it will image your plate for you. And then each well has a certain control spot in it. So that tells the software where to place the grid and where to look for spots based on the product you're using. So it has an auto spot finding feature that makes spot finding much easier. It still has additional options to manually find spots. If you're having a trouble or need assistance, there are certain manual operations you can use as well. It is optimized for imaging Q-Plex arrays. We do have some customers that use this device as well for chemiluminescent Western blot imaging. Clearly, it's not designed for that purpose. The camera and the lens we chose are for these plates and not for Western blots, but it can be used, and we do have some technical support features as well as blot finding tools in the software to assist you if that is something you choose to do. Maybe I'll just quickly let a blurb out here. Just in the coming weeks, we will be releasing a new device. This is what we're calling the Acuvue Imager Pro. This is a device that is going to be has a higher quality camera. It will provide higher low-end reproducibility, so we're going to get better precision at the low end. It does have automated deck so that you can integrate the device more easily with high-throughput instrumentation. So a lot of our clinical partners are already purchasing this device for their high-throughput environments and with liquid handling devices. You can actually visit our website and go to Acuvue Imager, and you'll see a page on Acuvue Imager Pro, and you can take a look at that. That device will be coming out in the near future. Now, you may not have this device, or you may want to evaluate the technology. So we have validated these kits with 3 other product lines. The first is the Fujifilm LAS 3000 or 4000, and this is technology has now been purchased from GE. If you use these devices, we highly recommend what they call an NP tray. The NP tray is simply a tray of a parallax lens that sits over the plate and allows the user to see the bottom of the most outside wells on a plate. Due to the optical angle of light, sometimes seeing in the bottom of those outside wells is difficult, and that parallax lens helps you do that. The two other, we do have validation procedures with both the BioRed ChemiDoc XRS and the VersaDoc, as well as the Lycor Odyssey scanner. Each of these devices, if you go to our website, there are technical write-ups on how to use these devices, as well as a video that you can watch on how to use these devices with your Qplex kit. So we strongly encourage you to read these pages. If that's the device you have, contact our technical support. You can contact them here. There's an email, techsupp, TECHSUPP, @quansysbio.com. Email your question about any of these devices, and we'll give you whatever assistance we can. So there's quite a, being that we manufacture this Qplex technology, there's a lot of ancillary services that we have that we've generated due to how we've developed this technology. Some things we do are custom printing. Some of our customers, due to the research component of their interest, they simply need custom printing services. They don't have complete assays. They're simply looking for, let's say, an antibody response to a certain antigen. We'll actually print those antigens down in a custom plate, send them the plates, and then they screen them based on their samples and on their own reagents. So we do some custom printing. We also do custom kits, and so as you can understand, we have a variety of assays available. Let me show you this sheet here. This is the current list of assays we have that customers can pick and choose from for custom kits. So you can see there's literally almost 100 different biomarkers that you can pick and choose and put into your plate that you want. So what we recommend you do is get this list and compile the assay that you want, and then send that to Quansys, and we'll let you know if we can or cannot do it. There may be some assays you have that you'd like to add to this that you don't see. Please contact us. There's a whole list of products that are being developed currently in-house, some of them for private applications, some of them with assays that we'll be able to have down the road, or then we can communicate that to you. In some cases, we've actually built assays for customers for some products that are projects that are larger in scale. You know, if they have quite a sizable project and they need custom assays, that's definitely a service we can offer and have done so with much success. And there's a case study I'll be talking about one of those examples. So that's kind of the way we do our custom kits. The time frame to receive those kits, if your assay is on that list and we agree that we can do it, the time frame to manufacture can range from 5 to 10 days to up to 20 days, depending on the biomarkers you choose, because some of those biomarkers may require lyophilization or some method of processing to ensure you'll have good results. So once you make that request, we'll provide pricing and a time frame. As mentioned, we also do some assay development, so if you see new biomarkers that you would like to build, we have that capability of building those. Like I mentioned before, we do have some case studies that we can share with you on how we've been able to do that. So just a quick comparison to how we see ourselves compared to traditional ELISAs. There's still a lot of people out there that are buying ELISAs one at a time. As you understand, there's a variety of ELISAs available in the marketplace. If you're using ELISAs from companies such as R&D Systems, you know, you're paying several $100s per kit. There's some cheaper ELISA kits out there. You pay less, but you definitely sacrifice in quality. So as we look at our technology compared to traditional ELISAs, trying to help people understand how it differs and what the issues are. So as you look at a traditional ELISA based on, you know, for let's say you're testing 16 different cytokines, you'll use around 25 to 50 microliters for the Qplex, whereas you'll use almost up to a mil for the 16 assays in traditional ELISAs. The protocol is very simple for traditional ELISA. People are familiar with that. The Qplex is a modified ELISA, so through the process of running your samples, it is the same, with the exception of imaging and data analysis, which are a little bit different, which do require learning and training. The time to run 16 different ELISAs could take up to 48 hours if you ran them straight, whereas the Qplex can take 3 hours for the same amount of data points. Data output, clearly you're only getting 96 data points per plate, whereas on ours you're getting 2,400 data points per plate. The cost, you're seeing is a higher cost per assay, mainly because you're spending $300 to $400 for an R&D systems kit, where you may pay 3 to 4 times that much for one of our kits, but you're getting 16 times the amount of data. So as you can see quickly, looking at that cost framework, it is more cost effective to multiplex. And because of, as I explained earlier, the signal to noise from the spot to the background, which for your information is something called the Eakins principle. You're more than welcome to look that up in the literature, but it's a very clear, it's a method in why you get better sensitivity in some of these array-based technologies. And then when you look at equipment, the traditional ELISA, your plate readers can range from 20 to 50,000. Our imaging device, US dollars, is somewhere around 10 to 15,000 based on what you purchase. So anyways, that just gives you an introductory view of how we compare to traditional ELISAs. One of the huge pros to traditional ELISAs is that there's an ELISA for almost anything, because they've been around for 50 plus years. There's just a whole variety of traditional ELISAs. Our list is set, and we're trying to expand that as fast as possible. When we started, that list was very short, and it is getting longer, but it takes time to build that list out and to provide quality assays. So that's one of the difficult parts about multiplexing, is that you have to make sure all your assays are available and can be tested in the same well environment. So as we compare ourselves to ELISA, we then talk about, well, how do we compare ourselves to the other multiplex tools in the marketplace? Right now, the big multiplex 800-pound gorilla is Luminex, and people constantly ask us how we compare to Luminex. I have a couple case studies I'll share in just a moment, a direct head-to-head comparison with Luminex. By each of these different parameters, I'd like to talk about how we differ. The time to run a Luminex compared to Qplex, it does take longer to run a Luminex, mainly because you're running them in a serial fashion, in the fact that each sample has to flow through that microfluidic line to be analyzed. It takes more time. Sample size is very similar. You can range from 12.5 to 50 microliters per well. High throughput, because every sample has to run serially, it takes longer. So hence, a lot of the big high throughput companies are not looking to Luminex for their applications, mainly because it just is a significant bottleneck when you're talking about thousands, if not millions, of samples per year. Qplex, because we're simply just taking a picture of the image and getting the next plate, and we can have that quick turnaround. It has a very easy introduction into high throughput environments. The protocol, because you're dealing with microfluidic beads, is more complicated. There's more sample preparation issues you have to deal with, bead processing issues. The Qplex, it's very similar to an ELISA, so you simply run it. The learning curve is easier for new people, so we see the protocol as being easier with the Qplex technology. When looking at the equipment, again, you're looking at 50 to 100,000 for the basic Luminex device. Our device ranges anywhere from 10 to 15,000. Again, these are US dollars based on certain pricing scenarios. Sample types, because you have to run that through a microfluidic line, you have to ensure that your sample is prepared appropriately. Tissues with high lipid serum content or any kind of fatty content or tissue homogenants will have problems in the Luminex model. They can clog up those lines, and then your device is going to be down until you get a technical representative there. In converse, the Qplex technology, because it's an open format, meaning the open wells, you simply can load anything you want in there, let it react, and then wash out your wells. So that allows for a lot of variety of different types of samples. Our kits are validated with serum and plasma, both EDTA and citrate preparation, but we have had other customers use them for a variety of tissue samples, anything from kidney, lung, liver, ocular solution, a whole variety of lung lavage, vaginal lavage, a whole variety of different types of samples can be used. Urine, tears. So what's critical here is we validated for serum and plasma, and any additional type of samples you use, you need to ensure that you're getting the performance you need, and or we can help you with that. Bead variation is an issue with the Luminex, and the fact that as they manufacture these different lots of beads, you will get different responses. Our QC criteria for intra and interplate CV is 10 to 15%. So we have a variety of controls, both high, medium, and low, that have to pass that CV% in order for the plate to be released. Sensitivity, I've spoken about that. You get higher sensitivity when you compare the spot directly to the background. That's more difficult in a Luminex model. Hence, the sensitivity levels in the Luminex are always around picogram per mil range, where the Qplex is in the femtogram per mil range, using the Cytokine kit as an example. And price per assay, Qplex is less than the Luminex. Depending on your providers, it can be ranged from 20 to 40% less than Luminex, the kits alone. So a few case studies I want to talk about today, representing a few different principles I want to share. The first is our ability to manufacture clinical grade assays. So the first case study is called Validation of a Custom Multiplex Array Against Individual ELISAs. This is a project we did with Simon Fraser University in British Columbia, Canada. This project was based on a female reproductive health study they were doing, analyzing thousands of urine samples from Guatemala. They were assessing the health of these women based off these 6 different hormones: adiponectin, cortisol, E1G, FSH beta, HCG beta, and C-peptide. What was tricky about these is they have different analytical ranges, meaning some of these assays are to be measured in the nanogram per mil range, others in the microgram per mil range. Now, multiplexing, if you have to do multiple dilutions in a multiplex, you're kind of nullifying the reason to multiplex. So it's important that as we develop these kits, we build them for one single dilution factor. So as we built these, we took that into consideration. And so what we do is some of these assays we build in a competitive format. And if some of you aren't familiar with what a competitive assay is, that's simply where we print down an antibody, and then when we add the sample, we dilute the sample containing the antigen we're trying to measure, but that antigen is labeled. So what we're doing is looking at the competitive rate, or the rate at which these antigens are binding to this antibody, meaning the higher percent of labeled that binds tells us that there's not that much in the sample. Or if not that much labeled antigen binds, then we know there's a lot in the sample. And that can be quantitative, and it's a very well-known method in the industry. So by combining those 3 sandwich ELISAs with the 3 competitive assays, we're able to have one single dilution factor that will work with our customer samples and give them the maximum benefit of multiplexing. So this testing was done in parallel to a Bayer ACS 180 clinical analyzer. So what they did is they took these thousands, I think 4,000 samples, tested them on this clinical analyzer, received the data, and then tested those exact same samples on the Qplex technology. With a Pearson correlation coefficient of 0.75, and they published this in the American Journal of Human Biology. Here are the scatter plots for each of these assays. As you can see, some are tight, some are not so tight, but based on their correlation criteria, these assays met the specification they needed, so they could move from this clinical analyzer, which cost them hundreds of thousands of dollars, to this more efficient model to use. If you look here, you can see the different sensitivity levels between the 2 platforms, as well as the inter-assay and intra-assay CVs. You can see for the most part, with one exception, they're all below 10%. This is also shows the Quansys Multiplex was able to increase their sensitivity because that was a requirement they had. They wanted to not only compare to the clinical grade assay, but improve sensitivity so they could have higher differentiation in the natural healthy population. In their summary, they stated this multiplex technology provides a more economic, rapid, and ecological sound alternative to individual assays for studies requiring the measurement of multiple biomarkers per biospecimen. So we're pretty happy with this. Again, we see this as being an example of Quansys' ability to manufacture clinical grade assays in direct comparison. The second case study that I'd like to talk about today was the project that was completed at Oregon Health Sciences University of Portland, Oregon. They wanted to compare a variety of multiplex technologies and compare them based on a variety of metrics. So what they were measuring is these were tissue samples. Again, these are tissue samples. These assays aren't specifically validated for tissue samples because, as you can understand, there's a whole ton of different tissues that can be assayed and a whole variety of different preparation procedures. So they took these tissue samples, got these kits, and ran them. They wanted to measure 5 different things: sensitivity, linearity, concordance to R&D Systems ELISAs, meaning if you measure IL-2 in R&D Systems ELISA, will you get the same, how close will your measurement be on a Q-Plex kit? And then cost effectiveness as far as cost per sample, and then as well as RT-PCR correlation. How well does the proteomic expression of a certain cytokine compare to the genomic expression? For the purpose of brevity and the fact that they didn't have a strong analytical representation of how these things compare in the publication that was suitable for presentation purposes, I simply just used their text that they used in their summary. Sensitivity, they showed both the Quansys and Aushon having the greatest sensitivity. Linearity, they gave Quansys the recognition for having the most linear response. If you see here, you can see as we dilute these samples down, irregardless of what dilution factor we use, we still get the same value as we back calculate based off the dilution. R&D System ELISA concordance, we had the best sensitivity to R&D systems, and the reason why is two things. First of all, every time we build an assay, we buy a control from R&D systems that we can use to reference the value of that assay, meaning we'll build an assay and we'll say, okay, well, we think it's measuring IL-2 at this level. We'll go out and buy the R&D Systems Quantikine kit, test those samples side by side, and calibrate or reference our assay to that measurement. Now, that gets the initial assay on track, but then what we also do is have what we call master calibrators. So we have these master controls that we store. We have a whole bank of them, and we reference those controls as well. So as we manufacture new lots of product, that each of those lots will have the same level or same value of IL-2. So that's why you see a higher correlation to R&D Systems ELISAs here. With regards to RT-PCR, both Aushon and Quansys match closely, and then taking into account the lower price device and kits, the Quansys platform is the most cost-effective multiplex solution in their review. So their conclusion, thus, the multiplex ELISA procedures appear suitable and reliable for the study of hearing-related proteins, providing accurate, quantitative, reproducible results with considerable improvement in sensitivity and economy. Okay, the third case study and final case study is a project we did with a company called Avere out of Irvine, California. So this company had a proprietary panel used to assess cardiac health and the cardiac risk of a patient. So in essence, they measure for these 7 different biomarkers. They then take the BMI of the patient, they take the sex, the age, the history, and they give the patient a score, meaning what is their risk factor for some kind of cardiac event so that proper preventative activities can occur. They were using both Luminex and MSD as a multiplex solution initially, so they're actually testing both a Luminex kit, MSD kit, and they also had one Singleplex kit for each sample. So they would receive one sample, they test on Luminex, MSD, and single ELISA to get their data. Luminex and MSD were unable to put those kits all in one well, and so when they ran into us several years ago, they said, hey, let's try this. So we were able to build a single panel for all 7 of those assays for their CLIA use. We manufacture this in our GMP environment. As you may or may not know, we are a GMP facility as well as ISO 13485 and 9001. So we're able to manufacture these based off the FDA requirements and provide them products to be used. So as you can understand, providing them one kit instead of 3 and the efficiencies of sample and time, this is a great cost savings to them to multiplex these into one panel. When you compare direct head-to-head to the MSD and the Luminex, you can see we're able to reduce their intra-assay CV by almost 2%, 2.5%, and the inter-assay CV by 1.8%. So 1.6, sorry. So they were pretty pleased with the improved reproducibility. When you look at the limits of detection, they are very similar. You may look at SFAS on the bottom of that top chart of the 202 picogram per mil LOD. This is actually their specification. The Luminex assay was too sensitive. So pretty much every assay they had was overshooting, and they were getting high values and high signals and a lot of saturation. So as we developed this kit, because of our development capabilities in-house, we're able to build that kit around their specifications. So you can see this is the scatter plot they had when comparing the Luminex and MSD to the Quansys. You can see the regression model and how well it fit. Their conclusion, while providing a more cost-effective technology than the XMAP, MSD, Qplex also combine the 7 protein assays of the MyRisk VP test into one format, streamlining the testing and minimizing the hands-on time to obtain a patient's CHD risk score. I think this is another example of showing that Quansys can, A, manufacture clinical-grade assays based off of our technology and our ability to find antibodies, antigens in the market, find the controls, and build to a certain level of specification. And then when we do build those kits, they can compete to other clinical-grade products, and then we can save customers a lot of money and time with these applications.